and we'll get started and I'll let other people in as they show up. So welcome to our second ever Big Ideas Colloquium. Today, I am delighted to introduce David Williamson Shaffer. He is the Sears Bascom Professor of Learning Analytics and the Villas Distinguished Professor of Learning Sciences at the University of Wisconsin-Madison, and a data philosopher at the Wisconsin Center for Education Research. Dr. Shaffer earned his PhD from the Media Lab at MIT. He's taught at Harvard and has served as the European Union Marie Curie Fellow. His research interest is focused on merging statistics and qualitative methods to construct models of complex and collaborative human activities. His work has led to a suite of tools being used by more than 1,000 researchers in over 20 countries. He's authored more than 250 publications with over 100 co-authors, including 2 books. And some of those co-authors have been from UMass Dartmouth. And I am delighted to have David here today to talk to us about quantitative ethnography as a way of thinking about and attacking the questions we ask about big data. Turn it over to David.
All right, well, thank you very much. Yes, and in fact, one of those co-authors was Jim Caput, for whom the Caput Center is named, so which was a great honor for me. So let me just go ahead and share my screen. Thanks so much for inviting me, Chandra. It's always great to see you, and of course, folks at the Caput Center. What I'd like to talk about today is, sorry, I'm messing around with it with the way that Zoom gets in your way when you're trying to show slides. What I'd like to talk about today is, well, basically what we're trying to do with all of science. In all of science, or at least social science, well, I guess it's true of all science, there's something that happens in the world, some activity, and then we want to make some claim about it. And the process of science is ultimately somehow going from the activity in the world to that claim. And hopefully we do that in a way that actually is meaningful and not just kind of a byproduct of the particular tools that we've chosen and the particular biases that we've brought. Now, there's a fairly well-formed way this happens. We could call it the primary modeling pathway, which is the way it's referred to in evidence-centered design, which basically is there's an activity. We make some observation or observations of activity. We convert those observations into some systematic set of data. We encode that data in some way, which may be as much as just identifying the variables. We construct some model, whether that's a qualitative or quantitative model, and then we make a claim based on that model. The thing I'd like to point out, though, is that at each step in that pathway, we lose information. Here's what I mean by that. So an activity in the world is full of information. All sorts of things are happening. Students are talking and there's noise and there's things being written and things happening on a computer. And we only record some part of the information that's in that activity. And then more or less because the activity happened and is done, we forget about the activity and we focus on the data that we've recorded. And then in some way we encode that data. Right? We make some claims about the properties of the data, and then we more or less forget about the data and we just work with the codes, and we use those codes to construct some kind of a model. Now that could be a qualitative model, it could be a process model, it could be a quantitative model, but whatever kind of model we make, it's important to remember that that model contains both signal and noise. There are parts that are meaningful and there are parts that are just noise, and what we can do is think about this in terms of a signal to noise ratio. That is, how much signal is there relative to the amount of noise? And if we can reduce the noise, it's easier to see the useful information. And this is really good, because even though we've thrown away information in order to construct this model, we've thrown away a ton of information. The idea is that we get less information at each step, but the useful information becomes more and more clear. That is, the claim has less information than the activity, but it contains the important information. And now this is important to recognize because it means that at each step, what we're basically doing is deciding what's signal and what's noise. What part of the activity or the observation or the data or the coding or the model actually matter, which parts don't. And so we have to ask ourselves, well, how do we know we've identified the noise correctly? We mistake signal for noise, we're going to get nonsense out the other end. Well, there's a few different ways to think about that. One is that we actually need to be able to trace our steps back. That is, we need to be able to go back from the claim to the model and see how the model actually represents our claim, go back from the model to the coding and see whether or not the coding that is represented in the model is actually consistent with the claim, go back to the data and do the same thing. And this in quantitative ethnography, we call closing the interpretive loop. It's basically going back to make sure that we didn't lose something important as we were doing this data reduction. But I'll make a second important point, that is, even if we can do this kind of post hoc analysis, we actually need some kind of theory to make these decisions. There is no way to do good research atheoretically. We can't simply throw things into some correlative model and hope that what we're going to get is sensible. And this theory can't just be theory in the abstract. It has to actually come from our understanding of the context, the interaction of some theory and the context in which we're working. And because the theory has to come from some context, that means that we have to have some systematic way of understanding the context in which we're working. And I'm going to argue that ethnography or qualitative methods more generally give us a way to do that. Why? Why ethnography? Well, because human activity happens in a cultural context. Well, let me give you a quick example of that, right? So I grew up in New York City. And so when I see dirt on the ground, the only thing I'm thinking is, gee, will my feet get muddy? And that comes from my own childhood culture as somebody who grew up in New York City, in this case, in the 1970s. Now, as Jim G argues, right, that every culture has what he calls a big D discourse, some way of using language, of feeling, of thinking, of believing, of valuing and acting that's part of the people in that culture. And I point this out because if I were an archaeologist instead of, well, what I do now, and instead of a kid from New York in the 1970s, I would look at dirt differently. When I looked at dirt, I would be thinking about whether or not it contained evidence about activities that had happened in the past. Things like, well, post holes, right? If you dig a hole in the ground and you put a post in so that you can build a fence and fence in animals or keep out animals or protect yourself from other people who might be trying to take your stuff, when that post rots away over many, many years, it leaves a patch of dirt that looks different than the earth around it, which is why archaeologists use something called a Munsell color chart to carefully analyze the color of soil in a systematic way. They do a bunch of other things like actually tasting the soil and rubbing it on their teeth and so on. So I'm kind of glad I'm not an archaeologist. But the point here is that these terms, soil and Munsell color chart and post hole, these are all codes in the culture of archaeology. And what I mean by that is that these are all culturally relevant and meaningful parts of the discourse of archaeology. They're the things that, if you're an archaeologist, you pay attention to. But let's notice that these codes don't just exist free floating. They're related to one another in the sense that an archaeologist uses a Munsell color chart to analyze soil in order to see whether there are things like post holes. That is, what matters to being an archaeologist is not just that you know what a Munsell color chart or a post hole is or what soil is, you know how those things are related to one another. Put another way, right, the codes are part of the discourse of a culture. And we interpret a culture by showing how those codes are related to one another. So let me give you an example so that we're talking about something that's a little more concrete and maybe a little more math and science like. So the example I'm going to give you is from a simulation, where students are building a robot using a jigsaw pedagogy, right? So groups work on one part of the design problem, and then they regroup to solve the whole problem. And I'm just going to show you a little bit of data from right after this regrouping. So the students have a mentor, Justin Kim, who asked them to introduce themselves. And then we can see that they all basically introduce themselves. They talk about who they are and which group they work with. And the conversation takes a turn when one student asked about the results of the prior group's work. So what was everyone's results? And what happens is the students respond by explaining how their previous prototypes performed. Safety was close to the company requirement. We were able to reach all the internal consultant requests and so on. In other words, they're talking about the technical requirements of the device, the robot they were building. Conversation takes another turn when Michael says, okay, but what were the results of your best prototype? In other words, he's actually asking for the data. He wants the numbers that they actually got, not just that it was good, but like how good. And we see the students respond by talking about the specific data. Recharge interval was 8.7. The cost was $14,540. The payload was 522, and so on. And then the conversation takes another turn when Elizabeth, having heard all this data, says, I think we need to determine which attributes are the most important to us so we can meet those requests and so on. In other words, she starts talking about design trade-offs. And if you know anything about the science of design, this idea of trading off pros and cons is kind of the critical part of engineering design and any other kind of design, really. So if I want to sort of summarize this story, right, it's that the students started by talking about collaboration, they talked about technical requirements, and then what happened is they needed data in order to consider design trade-offs. And what happened as the story progressed is that they basically circled around design trade-offs, technical requirements, data, until they came up with a final prototype. So what I just told you is fundamentally a qualitative story. There was an activity, there was qualitative observations made. I presented some qualitative data. I showed you how that data was encoded. I constructed a model and I made a claim about their activity. And although, of course, this was nothing like a real ethnography, this was a little kind of cartoon, little amuse-bouche of qualitative methods. But if I had done a full qualitative analysis, right, I would have gotten two things. I would have gotten interpretability, that is, I would have understood what was happening. And I would reach theoretical saturation. That is, I'd reach the point where if I looked at more and more data or told you more and more stories, you would start to see the same thing over and over again. Now, of course, we can also make a quantitative model of this context. And in the learning sciences and allied fields, we do this all the time. One of the most common methods is coding and counting. So in coding and counting, we look at the coded data and we, well, count how many times each code appears. And then we do something with those counts. We compare experts and novices, and we compare the number of times that they did it, and we can do a chi-squared test or a t-test or run regression or whatever. Before we go forward, let's just point out this is a really strange theory about how people communicate, because the number of codes stays the same regardless of what order the people are talking in. So it's a theory of language which says all that matters is what you say, and the fact that you say it in some different order has no bearing on how it is that people understand what you're saying, which is, again, sort of odd. We can get around this problem by using something like a Markov or state transition model to see how the codes follow each other. So for example, in a Markov model, we would look at technical requirements goes to technical requirements goes to technical requirements. So that's two transitions from technical requirements to technical requirements. And then we can compute say the transition probabilities. What's the likelihood that you go from one thing to another? There are a couple of issues with this. One is it counts immediate transitions from one thing to the next, but if there's a gap, we might not see that, in fact, what happened was that Michael's discussion of data was in response to these previous discussions of technical requirements, even though there was sort of a gap in between them. The other thing, of course, is that this is a representation that's a little hard to read. And, well, it's hard to compare. So, for example, if we look at these two state transition diagrams, it's a little hard to see that, well, they're actually the same. They just look different because there's no standard way of positioning the nodes in a state transition diagram. Another approach that people use is called sequential pattern mining. For those of you who are not familiar, basically look at these sequences of codes. So in this case, it would be technical requirements, then technical requirements, then technical requirements, then data. What it means is that in sequential pattern mining, we actually care about the very precise sequence in which things happen, which leads us to wonder, well, does the precise order actually matter when you're solving a complex problem? Is collaboration followed by technical requirements followed by data fundamentally different than collaboration followed by data followed by technical requirements, or technical requirements followed by collaboration followed by data, and so on, right? We get a kind of explosion of codes or explosion of variables as we introduce more and more codes and more sequences. And as a result, we get, well, results that are kind of hard to interpret. So this is looking at the sequence from the sequences that have the highest support, which means that they are the sequences that most influence the results, right? And we kind of do what I would call sort of the squint test. We kind of squint our eyes and go, oh, that first dimension, principal component 1, has to do with data. It's when you talk a lot about data versus talking about other things. But if all we're going to do is ask, well, how much do you talk about data versus talking about other things? We could just code and count. It doesn't actually get us that much. There's another approach, supervised machine learning or neural networks. This is basically we give the machine the data and the codes, and we let it learn some black box model, and it takes all the data and the codes and it spits out some number, makes some prediction about whether or not, I don't know, the students were high performing or low performing or experts or novices or whatever we're predicting. And we don't actually explain and understand why, just this combination of things leads to this prediction. So quantitative ethnography takes a fundamentally different approach to these ways of making a quantitative model of this kind of qualitative data. So in quantitative ethnography, we do start with the coded data, and we construct what we call the common ground for each line of data. So here, as Gabrielle is speaking, what we're asking is, what is she actually responding to? Right? Well, the common ground is the things that she was responding to. In this case, what Zachary and Daniel are saying. So now we can think about this common ground as like a little window that moves through the data. Each line of data has its common ground. And as we're moving through the data, what we're looking for is places where the line of talk makes some connection between one of the codes that the person is saying and some other codes that exist previously in the data. And then when we see this connection, in this case, between technical requirements and data, we just make a connection in a network. Network is just a connection of things. We have the codes here, so we mark a connection. Now, different lines of data are going to make, well, different connections between codes. Some of them connect more than one code. And if we imagine adding up all of the connections that are made across all of the lines of data from a given student or a group of students or whatever it is we're adding up, we get a network model of the way in which that student or those students were talking and thinking about the problem that they were working on. This process is called epistemic network analysis. And what I'd like to do is just show you a little movie to give you a sort of sense of how this works. I'll talk a little bit more about the math behind it in a moment. Just a trigger warning, the video discusses infanticide. So if that's something that troubles you, feel free to shut off the sound or close your eyes. You'll hear sound, and there's also a transcript at the top for those of you for whom the sound doesn't quite work.
Her affect was flat, almost dissociative.
You think she's setting the stage for a psych defense?
Well, it'll be hard going if she is.
Because she's faking it.
No, because DSM-4 diagnostic standards still don't exist for postpartum psychiatric illnesses.
Here we go.
Many courts bar its admission. That's the reason why infanticide sentences vary so wildly in this country. Some women are given the death penalty, and others are given probation.
You think postpartum depression should excuse murdering your child?
It's not depression. I think she's suffering from postpartum psychosis.
Giving birth made her crazy.
It's a hormonal imbalance stemming from pregnancy. Its onset can be quick and severe. Its symptoms include agitation, hallucinations, delusions.
The Andrea Yates defense.
Look, the only thing making this girl crazy is the baby's father. I don't know what part he played, but I know that he's involved.
Liv.
So as we're watching this discussion between George and Donald and Olivia, we have a very strong sense that they are looking at the situation differently. And what these network diagrams do is give us a way of quantifying the differences in the way they're talking and thinking about this woman who has killed her child. For those of you who are familiar with Law and Order, of course, you'll notice that Olivia's model looks different, very different from the others. And of course, Olivia's always right. So it was actually the baby's father played a role in it. But I won't spoil the episode for you in case you want to watch it sometime. In any case, so if this is the basic idea of epistemic network analysis, let me show you the ENA model for the group that we were just looking at. So for example, here's Michael's network. If you remember, Michael was the person who asked for data in response to the discussion of technical requirements, and that's the connection right there between data and technical requirements. Elizabeth, if you remember, connects data and design trade-offs, and that makes sense because she was the one who brought up design trade-offs at the end in response to the discussion of data. Now, some of you may be thinking, hey, wait a minute, like you just put up these nodes and made a network, like where did all this come from? Well, what I can say is that these nodes are placed using a regression model, and I'm not going to explain how here. I'm happy to talk about that in the questions. It's been written about a lot, and it's an interesting story, but not one that's particularly relevant right now. What is relevant is that the way the optimization works is that each student has an ENA point in the model. They're represented by some point in this space. And the nodes are optimized so that the points that are on the right-hand side have strong connections overall in their networks on the right-hand side. Points that are on the left-hand side have stronger connections that are on the left-hand side. So for example, Michael's data point is up and to the right. Why? Because his connections are up and to the right. Elizabeth's point is lower down because her strongest connections are lower down in the space. And what this means is that if we find another student, say Zachary, we can make a prediction that his connections are going to be even lower down in the space, which is in fact what happens. What this means is that we can now look at many students at once. Instead of just looking at one group of a few students, we can look at a whole group of students, maybe a whole group of more advanced students who use this engineering simulation. We can find their mean point in the space. We can construct their mean network, which not surprisingly has strong connections on the right because their mean is on the right. We can see what the strong connections are. We could look at more than one group. We could look at a group of novices. We could see their mean network. We could see that their connections in this case are on the left, which means we can also compare groups. So we can look at the two groups and their means and compare their means, in this case, statistically. We can make a quantitative model. And we can understand, well, where are those differences coming from? In this case, right, the differences are that the novices focus more on collaboration and the experts focus more, well, on connections to data. And this sort of makes sense if I took a bunch of engineering students who had never done engineering design before, these are freshmen, and I said, okay, go design a robot. Well, the first thing they'd have to figure out is like, well, who's supposed to do what? If you're more advanced, you've done this kind of thing before, you kind of know the drill and you don't have to worry so much about what the process is going to look like. You can focus more on the actual solving of the engineering problem. And what I'll point out, though, is that this actually quantifies, well, our original qualitative description. Maybe it's a little easier to visualize this way, right? And this isn't so surprising because the group that I showed you data from was from more advanced students. And so they were moving very quickly from collaboration into the heart of the matter, which was this discussion of technical requirements, data, and design trade-offs. Now, the point I'd like to make about this, though, is that this represents a tremendous compression of data. Each of these data points basically represents a half a semester of students working in a class, collaborating around robotic design. But because of the way we've constructed it, each of those points, if we focus on any one point, it is represented by a network that describes the way in which the students were making connections between these ideas. And if we can drill down and look at any of the connections in the network and actually go back to the data and see where those connections are being made. In other words, if we take this quantitative ethnographic approach, in this case using ENA, we get something that's more than a mixed model. It's not just that we did a qualitative analysis and a quantitative analysis and we triangulated to see whether they told us the same thing. What we get is meaningful patterns because we actually were able to see them qualitatively. We get interpretability and theoretical saturation. And we can test whether or not those patterns repeat in the data. We get a formal testability, an internal generalization, where we can see whether there's a pattern and whether that pattern has statistical significance. In other words, we're looking at the same data, the same model, and the same claim in two different ways. And this is important because ultimately what we want are models that are fair and valid, which means they should be transparent, they should be accurate, they should be interpretable, and they should be fair to subgroups. The fact that we have a model that we know is meaningful means that it's interpretable and means we have a way of judging its accuracy. We're not just taking the computer's word and we're not just checking to see whether or not there's a high accuracy. We actually can examine the model and see whether it means what we think it means. Formal testability, the fact that we can represent our model in a mathematical way, gives us a certain degree of transparency. It's repeatable and it's describable. And we can test whether or not it's fair to subgroups. We can actually see whether or not across many subgroups in the data, we're getting similar results. In other words, quantitative ethnography unifies qualitative and quantitative methods. At each stage, there's a way of representing the observations or the data or the coding or the model in both qualitative and quantitative terms. And this works because quantitative ethnography is based on a theory of how meaning works. It's based on the idea that meaning is a cultural phenomenon, that it's made by making connections between codes and a discourse, and it constructs a model that reflects that theory of meaning. There's a large network of people around the world. I think that number is actually closer to 800 than 500 in the quantitative ethnography community across 30 countries or more. There's publications, there's an online, there's a quantitative ethnographic society, there are online resources, including a data challenge, which I think is coming up soon, where scholars from around the world team up and they try and do a kind of data sprint, solving problems quickly as a team. There's also an international conference on quantitative ethnography, which I'll just draw your attention to. It's actually in Melbourne this year, very exciting place to go, in October. And if you are interested and take a look at the call for the proposals, one of the things you'll notice is that on July 1st, there's something, the due date is for something called the research agenda development, which is essentially a 2-page overview of a way in which you might be interested in using quantitative ethnography in your work. You get to present that at the conference and have an opportunity to discuss with, in a sort of formal way, with people who are more expert and also people who are your peers in quantitative ethnography. There are lots of great workshops that teach you more about what it is that I've described. So it's a cool thing. Chandra and I met up in Copenhagen until she threw her back out, and that was very unfortunate, but it's a fun crowd. Anyway, let me stop there and see if people have questions or things that they want to discuss. I just want to thank all of you for coming today. I know it's non-trivial to take time out of your day and sit online, which we all do too much of anyway. And I also want to thank the National Science Foundation, who sponsors this work and requires me to thank them every time I talk about it. So let me stop there, and I'm happy to chat about whatever you'd like to chat about.
Questions, anybody?
Hi.
Hi, Jake.
Hi, Jake.
An interesting talk. You had, I think this is probably one of the more mathematical talks that I've heard from applied to humanity or social sciences. But I do have a question. So you say from the activity going through various stages, you have lost information. Mm-hmm. I guess two-part questions. First part is, which of the stages where you think that most information is lost? And second is that, is there a way to kind of characterize the amount of information lost? I'm from physics, so we think of entropy is a piece that contains information. So does that factor into any of the modeling?
So typically we're not directly factoring something like entropy into models. I'm thinking of information, and basically I think the similar way that physical scientists do. So it's essentially the number of bits that it would take to represent something uniquely. So from that point of view, the biggest loss is between activity and observation, right? The number of bits that it takes to represent the real world is way larger than any number of bits that we could record. After that, I would say probably the biggest compression is, well, it depends on how many data points you have. It's either between the data and the coding, or the coding and the model. But yeah, so you can think about this as essentially equivalent to removing entropy from a system, or at least removing entropy from your analysis of a system and focusing on what is systematic as opposed to what's basically random. The trick, of course, is figuring out what parts are systematic and what parts are random. So if you imagine, you're looking at something like an ideal gas. Okay, so it's bouncing all around in a container, and you believe that there are some molecules that are functioning systematically differently. That is, they're not moving at random. Well, first of all, that already is saying that that's more important than something else, because a bunch of the other molecules may be moving at random. But even so, making the decision that you're going to ignore all those other molecules and just focus on the systematic ones is essentially a loss of the total amount of information that's in the system. It's total amount of information. Some of it is noise. The random stuff is noise, but it's a loss of the total information. Is that the way you think about it from a physical point of view? I mean, there is a way of saying that the randomness has no information in it at all. The challenge is determining what's random and what's not, is maybe a way of putting it.
Yeah, it's interesting you mentioned the ideal gas model, because historically people have thought of ways to, beat the game of entropy. We think that thermodynamically entropy always increases, but people have been trying to come up with schemes to see how we can actually make entropy decrease without some other consequence.
Yeah.
So exactly what you mentioned, that you try to get some randomness out of system. There are many models. One model I think might be interesting is that you say you have some sort of daemon, okay, that's something that's invisible outside the system and that doesn't do much to your system. So watch the molecule. If a molecule goes to the right and you make a mark on it, right? Only mark this molecule and take them out. And this way you kind of decrease the entropy. But turns out in the end, you never do that, of course. So, yeah.
Right. I mean, that's, I guess, yes.
So what happens is whatever you take out, it's a daemon somehow has to absorb that extra, entropy created. But anyway, very interesting talk. Yeah.
Yeah. Well, I mean, a way of thinking about that is that as you're making all these steps, if we believe that you're not actually ever removing the entropy, what that has to mean is that your claim, right, the more precise you make your claim, the broader your, effectively, the confidence interval, right? The less certain you can be about it. And all we're trying to do is find the right balance between those two things, I think. Collins, I see a hand up.
Yes. Just I want some clarification. Considering an assumption that I've always held, that probably in doing research, I'm always thinking that the more information you have before you begin your analysis, the more precise, say, you would your results and claims would be. But listening to you talk, it's like the amount of data in terms of the quantity of information that does not. I just want clarification that it might not be as useful as I thought previously.
Yeah,
because
that's a great question.
Yeah,
go ahead,
because I'm thinking, especially say in quantitative research, because you want there's people say that with numbers. Say if you do a research that you say, instead of having a research that has 10 people and one with say 100,000, many would assume that the one with 100,000 is more is more, depending on how it's done, but they might take that to produce more meaningful data. But I just you provided a different way of looking at this. Yeah, and thank you for your time.
That's a great question, or questions, and a great point. There's a few different ways of thinking about that. So the easiest place to start is actually sort of where you ended, I think. So if I have 100 people versus 100,000 people, or 1 million people, or 10 million people, or 100 million people's worth of data, what happens is with data about more people, I have more statistical power. What statistical power means is that I can find statistically significant differences, that is variability either between groups or between people, that is smaller and smaller, meaning a smaller effect size, meaning I can account for very small differences in the data. because I have so much of it. Well, the challenge that presents is that if I have enough data, essentially what I'm going to get is a whole bunch of statistical results, most of which are not actually going to be that interesting or important. So now, instead of focusing on the results with the biggest of impact that I can see with a smaller number of people, I now have tons and tons of results, and I kind of have to sort through them in some way. Literally having more and more information essentially just means that you start kind of drowning in the information. It's harder to figure out what's important and what's not. I think a more useful way of thinking about this is that what you want to do is collect the kind of information that's going to be useful to answer the question that you want to answer. And that requires having some theoretical understanding of the situation and the question and the relationship between them. When I was a graduate student, I proposed to my advisor that I was looking at the geometer sketchpad, which is like GeoGebra for those of you who are in math education. It's a dynamic geometry system. And I was going to record all the things that the students did on the screen and everything that they said. And I was going to use all this information to understand the relationship between their artistic thinking and their mathematical thinking, something like that. And my advisor said, well, that's a terrible idea, because you're just collecting a whole bunch of data. You don't actually have a hypothesis in advance about like what the mechanisms are that you're collecting data about. And all that's going to happen is you're going to drown in your data, and maybe you'll find something and maybe you won't. But it won't necessarily have anything to do with either anything that's important or what it is you set out to do. So instead, I did what good graduate students do, and I actually had a hypothesis, meaning a small h hypothesis, a belief about what was important in the system, and I collected data to see whether or not that belief made sense and analyzed it and so on. All of which is just to say there's that what we want to do with the information is be thoughtful at each of these stages about what information we collect and what information we retain, because moving from activity to observation is based on some theory about what's worth observing. Converting your observations to data is based on some theory about how those observations are systematically organized. Moving from data to coding is based on some theory about what the important codes are in the data. That is, what are the important things that people are talking about or doing, or whatever your theory, whatever your data happens to be. Moving from codes to model is a theory about how those codes are related to one another and how meaning is being made. And moving from model to claim, of course, is theoretical as well. So in a sense, what you want to do is actually have a chain of theories, and you're kind of distributing the collection and reduction of information across those multiple theories, rather than just collecting as much information as you can and then trying to make sense of it later. So that was a very long answer, Collins. Is that helpful in terms of framing the issue?
Yes, it is. Thank you for your clarification, and thank you for the talk today.
Yeah. In another version of this talk, I frame it by saying that basically big data is bad. And of course, I don't mean that directly, but it's bad because the methods of research that we have, broadly speaking, qualitative and quantitative, are both based on scarcity. They were invented to solve problems at a time where getting data was expensive. Right? So what quantitative analysis does is it tries to come up with a way of making inferences when I have very little data about a whole lot of people. Qualitative methods are designed to make inferences when I have a lot of data, but only about a very few people. Right? They're both based on the idea that collecting data is going to be expensive. When collecting data stops being expensive, then all of a sudden I'm flooded with data. And now my quantitative techniques are basically overpowered. They're finding things that aren't that meaningful. And my qualitative techniques are overpowered in the sense that, well, first of all, I can't use all the data, but also I'm vulnerable to just finding examples that I want because, well, pretty much if I have enough data, I'm going to find some example of whatever it is I think is going on. So the solution is actually to bring these two things together. What quantitative ethnography is trying to do is find a way to make sure to leverage the fact that we have a lot of data and can quantitatively analyze it, but make sure that the patterns that we're finding and that we're testing are actually meaningful. That's really what's going on underneath the hood.
All right, thank you very much.
Yeah.
More questions? Stephen?
So I'll ask a question, and I apologize, I missed the beginning of your talk because one of our students was presenting in a 3-minute thesis. And so I was there supporting the student. So I guess, and so since I missed the beginning, I'm just going to ask this question and see what your thoughts are on this. When I think about ethnography and I talk about ethnography with our students, I'm really talking about an investigation that's really looking at what is the culture of something. And so in quantitative ethnography, like how does culture find its way into the investigation?
Yeah, so I'm not sure exactly when you came in, but the idea of quantitative ethnography is that every culture has what Jim G calls a big D discourse. That is, it's some particular way in which people interact with each other, short form, right? And that discourse is built out of codes. It's built out of the things that people notice. You could think about Charles Goodwin's idea of professional vision if you want. You can just think about the idea of coding, as you do it as an ethnographer. You could think about coding as sort of the EMIC codes, however you want to look at it. Right? In order to tell a story, I have to be able to point at particular things in the data and say, here's what's happening here. This is what this means. This is what this means. And in order to tell that story, I have to talk about how this meaning this and this meaning that and this meaning this other thing are all connected to one another. That's basically what storytelling looks like in an ethnographic context. I have to identify what the codes are and talk about their systematic relationships. And so all the quantitative ethnography is doing is saying, okay, well, if I'm talking about codes and their systematic relationships, is there some way to represent that mathematically? In ENA, the idea is that, well, I'm talking about how things are systematically related. That's basically a network, which is, of course, just a matrix, which is a mathematical object. And so I can do a bunch of mathematical transformations in order to test whether a set of matrices are similar or different, or what's similar or different about them, or whatever it is that I want to test. So basically, the idea is I come up with a qualitative story, and I can do that in exactly the ways that I always would come up with an ethnographic story. Mm-hmm. And now I have a bunch of codes, and I'm making, and you could literally say, I'm going to show you my qualitative example. And that qualitative example will show some relationship among the codes that I think is significant. And now I can test whether or not that pattern repeats. And of course, in a typical ethnographic case, right, I haven't investigated more than just a subset of individuals. So you could ask, well, what does it mean to test whether that pattern repeats? Right? The idea of statistics is always I'm testing whether or not the properties of some sample generalize to some larger population. But in this case, there's no sensible larger population. If I'm looking at a group of students and I'm making some claim about what they did, I'm pretty clearly not generalizing to all students because I'm just looking at this group of students. What I'm doing is it's called internal generalization. I'm basically generalizing to the hypothetical population, which would be, well, what if I could watch these students doing this over and over again, right? There's going to be a certain number of things that are just random because, you know, random stuff happens as people are doing stuff. And there will be some systematic things that they're doing because that's the way that they're actually thinking about the problem. And if I did this a whole bunch of times, right, which parts would just kind of be random and which parts would be systematic? Basically, what I'm warranting is theoretical saturation. I'm warranting that if I kept collecting data about these students, I would see these same patterns over and over again because they're not random. They're actually a property of what these students are doing. Now, does that make a quantitative ethnographic claim better than just talking about it qualitatively? Well, no. I mean, first of all, if the qualitative claim is nonsense, then the quantitative ethnographic claim is too. But more to the point, you can make a perfectly good qualitative argument without any quantification. What quantification gets you is an additional warrant. It gets you an additional warrant to theoretical saturation.
Sure.
Is that required? No, but it's useful in the sense that if you kind of take up, you know, Popper's philosophy of science, right? We can't actually ever prove that anything is true. All we can do is try and prove it false and fail over and over again. So this is basically one more way of trying to prove that what we were the claim that we made was false. And if we fail to prove it's false, well, that gives us an additional warrant that it's true. There is another advantage though, which is that in many fields, mine included, but in many fields, qualitative methods are not seen as being as robust, as reliable, and in some cases are entirely ignored. So like in policy discussions, qualitative methods are almost routinely ignored. And what this does is it gives a way to do solid qualitative research and represent it in a language that can be heard by people who otherwise would only listen to quantitative claims. And because what we're trying to do is quantify, we're not trying to make a quantitative claim that kind of triangulates with the qualitative claim. We're actually trying to test the qualitative claim itself. That means that we're able to communicate more authentically. And so, for example, if you, if you're doing some kind of intervention in an indigenous population, right? The metrics for success of the intervention are very often not going to be aligned with the things that the people in the group care about, because they think about, in many indigenous groups, they think about things kind of more in terms of narratives and stories. So this is a way to take those ways of knowing and represent them in the policy debate in a way that gives them more weight. Similarly in medicine, right?
Sure.
Nobody listens to qualitative studies, but if you could quantify them in a way that you as a qualitative researcher think are legitimate, now you've amplified your voice. Now, again, does that make it actually more legitimate? No. Is it useful? Sure, could be.
That's helpful. Thank you. Appreciate that.
Sure. Thanks for the question.
I'm wondering, when you started working with ENA, you talked about it being an assessment tool. And I'm wondering if you still think about it through those lenses.
Well, the short answer, I think, is no. Meaning not that I don't think that it can be used as an assessment tool. It's just, I think that people who are interested in things other than assessment have taken it up and used it for a whole bunch of other things that don't necessarily look like assessment. So that's sort of the short answer. I mean, people are using it in medicine. People are using it as a purely descriptive tool. People are using it in what's sometimes called participatory QE. So the idea is that you construct a model, these kinds of models, and you re-represent it in a format that's going to be more consumable by somebody who's not a researcher, and get their feedback on it, and then play that feedback into the model. And so you sort of get a loop. So no, I don't think it's just about assessment. I think it's, and to the extent that it has been about assessment, I think it's mostly been about formative assessment, because it's most powerful when you can kind of catch when students are doing something that's productive or unproductive and represent that back to the teacher. Yeah, I mean, the thing about assessment is, in order to assess something, you have to have some standard against which it's being assessed. And there are lots of situations when people are using ENA where they don't necessarily have a standard in place.
Right, that makes sense.
Gregory, it looked like you were about to ask a question and then couldn't find the mute button, maybe?
Right. Can you hear me now? I think
I can, yeah.
You can. Okay. I have a question. The part I thought was very interesting was when you had the novices and you had the more experienced people. The novices looked at it in that example like they were more collaborative based, if I remember, and the experts were more data oriented. That really was interesting to me. I didn't know if you have found over the multiple times you've done this, like various patterns and collected those that like kind of can be generalized across different fields. Like, so for instance, you can almost predict, oh, those are beginners because you can see the way that they interact. And I just was curious if you had any other those type of insights.
Yeah, that's a good question. So the short answer is no. And it's no for a couple of reasons. One is that I focus more on the methodological side. So there are lots of people who are using ENA to analyze different kinds of data. But the ways in which they're setting up their analyses are different enough that I don't know that I could, that I'm able to see a pattern across all of them. That's also because the other part of the answer is I actually am not really sure that those kinds of patterns exist, or to the extent that they do exist, they're at such a general level that they don't tell us very much. So, one of the things that I think is really important about, well, learning, but really all human activity, is that it's situated. It's closely tied to the things that people are doing. So doctors actually think in very different ways than lawyers, and who think in very different ways than architects, who think in very different ways than engineers. Easy way to think about that is if I'm in the operating room, I want to listen to what the doctor says we should do next, not what the lawyer says we should do next. If the doctor makes a mistake and we're in court, I want to listen to what the lawyer says to do next and not what the doctor says to do next. So these are very different, relatively different ways of looking at the world. And that's why we have different professions and different communities. Not every, except at the very broad level of like novices know less and experts know more. I'm not really sure that I would be confident that there would be a lot of patterns to see, even if we were able to look across many fields and make models that were somehow comparable.
Okay, fair enough. Thank you.
Sure.
I just want to thank you for this presentation. I believe this was really informative. I know it was very informative for me because right now I have a career project, and like you said, sometimes I feel like a vacuum cleaner, like I have so much data and I feel like I'm drowning inside that data, right? And I have to constantly remind myself, to go back to the theory and then use the theory to go through the data. And the ways in which you've been talking about it, and it's not that I didn't know about ENA. It's been, it's been around long enough, that we know the credibility of this method, but the ways in which you were able to explain it to me, I think I was able to buy into it because I'm more on the qualitative side of the people, where I do believe that even though we have, those deep insights that we have into the meanings and activities and going into the depth of what's happening can actually give us the kinds of insights that we are unable to get otherwise. And I'm also convinced with what you are saying, although, there are good examples such as Gloria Lutson-Billings, her work, was purely qualitative. And we can all agree that she made one of the, biggest, impacts when it comes to policy and everything else, right? So it's not to discount some of the impact that the purely qualitative work had in our current education system. But I do agree with you. It's such a high, the ladder is so much higher and so much more difficult to prove, when we are facing, when we are doing qualitative work, especially in learning sciences. For some reason, I'm finding learning sciences community to be much more robust and much more, intricate, because I feel like I can always publish things when it comes to interview data, right? Like because it's so difficult to attest what you have in terms of what is said by the people. But whenever it is, like you said, observations, right? The interpretation of the observations and the claims that we are making and the models that we are creating from those interpretations, it's much more complex and much more difficult to convince. So you were able to convince me that this was, it's not that you needed to, right? So please don't get me wrong, but
No.
I was convinced that this is actually, I would actually recommend our doctoral students and who are watching this, this is really helpful. I'm going to actually ask a copy of this video from Chandra and rewatch it in my research meeting with my doctoral students. So thank you so much. This was phenomenal.
Well, thank you for saying so. I used to feel when I was a teacher that if I had in a whole year, if I had like actually made a positive impact on one kid, the whole year of teaching was worth it. When I go to a conference, I sort of feel like if I come away with one good idea, the whole conference was worth it, because my standards, my expectations are pretty low. So if I give a talk and one person actually says that they thought that what I was talking about was sensible, I take that as a win. So I appreciate it very much. And yeah, I would say to graduate students, interestingly, well, maybe not surprisingly, people who are relatively early in their careers, and especially graduate students, have been where the biggest uptake of quantitative ethnography is. And that sort of makes sense because they're the ones whose methodological thinking is still in flux. The conference is a really positive and supportive community. There's a doctoral consortium, and as part of the doctoral consortium, not only does the conference pay for all the doctoral students' expenses to come, but they pay for the doctoral students' advisors' expenses on the theory that a lot of advisors don't know enough about QE to be able to advise a dissertation. So there's actually a separate equivalent of a doctoral consortium, but it's the doctoral advisors consortium, where we talk about what it means to do a QE thesis and how you can support students who do it and so on. So you can apply for that. And I think the applications for that are due either end of April or end of May, but it might be worth taking a look at if this is something that you're interested in pursuing. But there's a very, very supportive community of people who work with QE. Chandra is one of the Chandra and I are probably two of the old timers in the community, not meaning to age both of us, but Chandra was around when ENA was done on a spreadsheet and more or less involved a lot of guesswork, but we've come a long way since then. But yeah, there's lots of resources for people who are interested. There's a webinar series. There's a QE sandbox event where people just sort of bring problems and talk about them online every month. So there's lots of opportunities to think about how these methods might be helpful in your own research.
Thank you very much. I apologize that I'm not turning on my video. I'm inside the house and I have to put on my headscarf and there's all these rituals that I need to do. So I apologize.
No worries. I'm sitting in a room where if I turn the blur off, you'd probably all gasp. So just
I really appreciate that. Thank you.
Just to build off of what you were saying about the conference, the one day I was able to go to the conference, the session that I was in, I think that this is just really interesting for people listening because it was, there were 3 papers. There was mine, which was looking at how teachers think about proportional reasoning. And we were comparing the different kinds of mental tools that teachers use when they solve proportion problems. Then there was a paper that was about pre-service teachers working in building a collaborative environment, basically kind of social communities of practice kinds of things. And then there was a paper that was looking at the emergence of a community on Twitter during the pandemic with museum workers who were minoritized. And I found it really interesting because the people in the room were able to say really smart things about all 3 papers. And it was a really interesting thing because normally when you go to a conference, it's about the content specifically. So you would never put those 3 papers together. So it's a very different kind of way of thinking about how things fit together too.
Yeah, I mean, not meaning to make this whole discussion with the conference. It's also as the old hands here know, there's small conferences and there are big conferences, and the smaller conferences always have a stronger sense of community. You actually get to meet people and talk to them. And there's a sense that when you go into a room, everybody's going to be speaking your language or some part of your language. You can go to ARA and, it's like a medieval carnival. You open one door and there's somebody biting the head off a live chicken, and you open another door and there's people doing some other crazy thing. So it does, these smaller conferences have advantages along those lines.
I'm wondering if, I know Collins was brave and asked a question. I'm wondering if any of our other students have questions to ask about Ali. Good. Another student question. Yay.
Thank you very much for the very enlightening session that we have with you together. And I have a question, I'm trying to understand how the things are working. And when we are collecting data, for example, if we are doing the same thing in a school in Fall River and the same thing is doing in another school, there will be differences between the data that we will collect. And these differences, of course, will be quantitative and qualitative too. And when we'll convert the data into codings, these differences will be preserved in that coding process. My question is, when we'll model the different codes, how much variance will we be able to preserve when modeling this whole thing?
So just maybe make sure you're talking about, so if you take the two data from the two places and you use different codes to model them, then it's difficult to compare them quantitatively because, so the codes are basically the place where your theory acquires one of its mechanical grips on the data. So the idea of mechanical grip comes from Andrew Pickering, who was wrote in Science Studies. Mangle of Practice is his most famous book. And he argued that phenomena in the world are kind of diffuse. It's hard. It's actually hard to, like, if you look at what happens, just, you know, pick out any classroom you walk into, there's so much going on that it's, you know, figuring out what to talk about is almost impossible. And that his argument was that you, as scientists, we create a series of machines. That's what he called them. I think of it as operationalization, but it's a series of ways of attaching to the phenomena in the world and progressively making sense of them. So the codes are sort of the way that you attach to your data, right? I have a setting, I've recorded the data, and now the codes are the way in which I say, these are the parts of the data that are meaningful. So if I have two different machines that I'm using to attach to two different kinds of data, it becomes hard to compare between them because, excuse me, we're looking at essentially we're comparing two different machines. Now, that doesn't mean it's impossible, right? You could compare by asking something about the structure of the relationships between the codes. They talk very densely about the topic they're talking about here, and they talk very loosely about the topic they talk about there. Literally, you could look at network density or something like that. But in general, if you want to do anything that links two sets of observations, you probably want to try and, excuse me, treat them as if they're equivalent, except for whatever differences there are between sites. This, of course, you know, raises all kinds of questions about like equity and fairness, because if I need to treat the two sites the same way, well, if this, you know, one site is from school with a lot of minoritized kids and the other isn't. And so, of course, there are tools that we can use to address those kinds of questions. But also, I think what it means is that you have to be very careful that if you're going to, say, choose a set of codes to use across the two sites, that you make sure that you're choosing codes that represent fairly both sites. And so ordinarily what I would say is, if you think the codes are very different between the two, well, first of all, you might want to ask, why am I comparing them anyway? But if there are differences, you probably want to actually merge those two code sets rather than just picking one or the other. Is that helpful, Ali?
Yes. It is certainly helpful for me, but when I was looking at the whole thing, I was thinking about the same thing. Means if we are choosing very specific codes among two different sites, or like we can have multiple sites, and we are still choosing very specific codes, then it means that we are losing a lot of data.
Well, I think the point is that you're always losing a lot of data. The question is whether what you're losing is the right thing. We want to lose data. That's the thing that's hard for people to sometimes really embrace, right? We actually want to throw away data. Throwing away data is the way that we make knowledge, right? If we just had data, we would drown. It's only by saying this is the data that's important that we actually establish, you know, that we know something. So we need to throw away the data. The trick is to throw away the right data. And so, yes, codes are deliberately throwing away a whole bunch of information, which is why you have to have some theory as to what information you should be saving and what you should be coding for. Even if that theory is that my code should be emic, that's still a theory. So
by the end of the day, when we are done with the model, how much variance will we be able to preserve between, like, when throwing away data and like keeping the data there?
Yeah. Well, I mean, it's a good question. So I don't know if where you are in your training, but as soon as you start taking qualitative methods classes, you'll find out that the answer to everything and every question in qualitative methods is it depends. So it's going to depend on the setting and the observations you've made and the data and the codes you've chosen and the model you've chosen. And, when you get to the end of the day, there'll be some amount of variance that you can account for. I mean, in a qualitative framework, you don't usually think in terms of variance, but the point is, if you would just think in terms of sort of variability, the amount of variability that you maintain is going to depend on what choices you've made along the way. And obviously, on the one hand, maintaining variability is good, and we want to do it. On the other hand, if we maximize on, we focus always on the things that are the most different across people, groups, in the data, whatever it is, it's very hard to tell a story at the end of the day, because all we have is a whole bunch of things that are deliberately chosen to maximize the variability in the data. Right? When we tell a story, we're always claiming that something is systematic, even if we're digging very deeply into just one student's experience. We're still saying that there's something systematic about what it is that they're doing, because when we're talking about human beings, right? Human beings don't have causes; we have reasons, and so and those reasons are always somehow systematically related to some other thing about us, right? So what we're always trying to do is uncover the reasons why somebody does something. So if what we're preserving is variability, right, it makes it harder and harder to find the systematicity. And there's a balance between those two things. We don't want to jump right in and say, okay, all we're going to do is choose the things that are all the same so we can say this is systematic, because, as you know, right, there's importance in the variability. On the other hand, we don't want to just say, well, we're going to just focus on the variability and not worry about anything systematic, because at the end of the day, what story do we have to tell other than that these things are very different? Which I guess itself is a form of systematicity, but a different form.
Thank you very much.
Yeah. Now, so no graduate student yet has asked what I think of as the hardest graduate student question, which is, this is all well and good, but how exactly am I supposed to be trained to do this when it more or less requires being deeply trained in qualitative methods and being deeply trained in quantitative methods? And I barely have enough time to do one or the other. And I think the answer is, well, first of all, I think the answer is that our notions of graduate training in the age of big data actually have to change. So we have focused primarily on training graduate students in essentially one discipline or silo, or call it what you want, right? We expect that they're going to go deep, and typically go deep in whatever expertise their advisor has. And I think increasingly, science that means anything, especially again in the age of big data and AI and all the other things that are going on, has to be transdisciplinary, which means that part of our training has to focus. We obviously have to have some area of expertise, but we have to also be trained, be thinking, be vigilant about our ability to speak across different disciplines, right? So in general, people who are doing quantitative ethnography are not necessarily deep experts in both qualitative and quantitative methods. Typically, the best work is done by people who are teaming up, where somebody has really deep qualitative expertise and somebody else has really good quantitative chops, and often a third person who actually knows something about quantitative ethnography, and they put all those things together, and that's where they get these kinds of analyses. So leaving aside the sort of systemic complaint that people like Stephen and Shaknoza and Chandra and I should be thinking about, I don't know who else is faculty here, so I'm just guessing, but right, from a point of view of an individual graduate student, the way that I think about it is you need to know enough about cognate fields, that is, the things that are not what you're studying but are relevant to what you're studying, to not get bluffed out of the game. Right? If you graduate with quantitative training and you know nothing about qualitative methods, the very first time you encounter somebody who starts to talk about a qualitative study, you have no good way of evaluating. You don't even know how to participate in the conversation because you don't know the discourse. You don't know that register. Contrary-wise, if you're only ever trained in qualitative methods and you believe, as sadly some people in qualitative methods are trained, that quantitative methods are evil, right? Then when somebody comes along with quantitative methods, they're gonna take their statistical canon and blow you out of the water, right? So you really have to at least know enough that you can be conversant, and as long as you have that, then you can think about partnering and collaborating and working with other people to do the kind of work that really can't be done just by somebody in one silo. I see a hand up.
Hello.
Uyoisa, is that how I pronounce your name? Anything close to correctly?
Yeah, close.
Okay, well there you go. That's all. That's what I'm going to get from looking at just tiny characters on the screen. Anyway, what's your question?
Yeah, thank you all very much. I listened to the session. I was like, wow, this is really amazing. Just a quick side note. Actually came in to spy on you because we studied your podcast about how to make a beautiful presentation for your conference prep for slide.
You're talking about Joel Amadon's
yes.
podcast? Yes.
Yes. So Dr. Amy Ellis, I don't know if you know her, she's in the math ed program here at UGA. So she recommended that we watch that, and it was amazing. We've really been doing that. So as a side note, she's like, guys, he's giving a speech, so you gotta go check out his slides if it's Schafferized. And I'm like, okay, I'm here. So anyway, thank you very much for it. It's really amazing. I love the slides, by the way. Beautiful work.
Oh, thank you.
Yeah. So my question is it okay? Yeah. So I have a very strong background in quantitative research. My master's was done in Nigeria, and in Nigeria we use more of quantitative methods. And now I'm in my first year at UGA in math ed with, we're doing the qualitative stuff. So I think I totally resonate with what you're doing right now. My question is so how do we go from here? Like all the faculty members I know of are grounded in qualitative methods, right? So do we I don't know, do we have to have someone on our panel that is grounded in quantitative methods to be able to pull this off, or what do you think about that?
Yeah. So the short answer to that is yes. I've served on a number of dissertation committees precisely because the advisor wanted usually you have to do something your advisor believes in, right? So usually I'm there because the advisor wants somebody else who can talk about whether or not what's being done in terms of QE is sensible. So yeah, that's the short answer is yes, you do need to find somebody. And this is of course why at the doctoral consortium at the conference, we actually invite advisors, because they need to think strategically about how to put together a committee to do something where not everybody on the committee is going to understand it. Al Cohen is not a bad choice for that if you're at UGA. So that's sort of sometimes the answers to questions are really simple and straightforward. That's one of them. I will say that sometimes what happens is, so keep in mind your first job as a graduate student is to stop being a graduate student, right? One of the things that sometimes happens is a committee will recommend, so somebody will do a quantitative ethnographic study, and sometimes a committee will say, this is great, but why don't you just do the qualitative part, because that's all you would need to do to graduate, and then you'll get your dissertation, and then you can go on and do the quantitative ethnographic part later. It's sort of unfortunate, but it happens a lot that graduate students are more ambitious in their community. The committee wants them to be, in terms of what they want to do for their study. And so a lot of the job of the committee is kind of saying, no, don't do that. Just do this part. So that sometimes does happen. Yeah, exactly, Stephen. So that does sometimes happen, but it's still, I think, helpful to have, if you're going to even start out with a quantitative ethnographic or mixed methods or whatever you're doing, you have to have somebody who sort of plays on both sides of the court. I'd just like to say, by the way, that so I have taught a course in the past about how to make effective PowerPoint presentations. And yes, Joel and I had a conversation based on him having taken the course about 15 years ago. And I actually didn't realize that was circulating around, although that's kind of cool to hear. But this is the first time that I've heard anybody come to a talk because they wanted to see the slides and didn't actually care about the content. So that's kind of cool. I appreciate it. I've had people come because they like the title, and even if they didn't know anything about the content. But this is the first time, just on principle, I wanted to see what the slides look like. So that's cool. And I'm glad you also enjoyed the content. But
thank you.
Your slides are very nice.
Thank you. I've had lots of practice. I mean, there are also some important psychological principles that go behind them, which it takes a whole course to unpack, and Joel and I barely do it justice in the in our little talk. But yeah, there's definitely ways of thinking systematically. But I mean, like anything, you're trying to present information. It's a communicative act, right? And so there are certain ways that you can communicate more effectively in the same way that you can, write prose that's more or less engaging. So the history of PowerPoint is that basically, it was originally designed to model what was done on transparencies. So the sort of just bullet points and so on is kind of core in its DNA. And so part of using PowerPoint effectively is actually rethinking the grammar of the slides themselves. That's a little teaser for what I teach in the course. I don't know. We're kind of off topic here, but.
Other questions?
I had a question. It's a really methodological question. I have experience of ethnographic research, and I was studying secondary schools culture ethnographically, and I remember I had huge data, like even my classroom observation or notes were like this much, like the notebooks, and also the video, audio recordings, like recordings are huge. But in analyzing those qualitatively, we expect like that data will be huge, and then managing those. I was doing that in Bangladesh, but now also I'm working with Dr. Kaimova and Dr. Oril in their projects, and in Dr. Kaimova's summer camp, we also have like huge data. So how do you methodologically want to like manage, or like before even going through the data, how do you, for quantitative ethnography, how do you initially do the task?
Yeah, that's a great question. I mean, one thing we should acknowledge is that ethnographers have always dealt with big data, not necessarily big data in the sense of, terabytes of data, but more data than you could actually analyze piece by piece. That people have done that all the time. And of course, you wind up partly focusing in on some parts of the data based on some combination of whatever prior theories and interests you had and what you were able to observe and kind of retain in your analytic notes, and also just the sort of sense of the setting and what's important as you were observing it if you've been collecting the data. So there's a certain amount of focusing that that happens naturally. There are, and I don't need to tell you or anybody else here, there are sort of number of different ways that qualitative researchers basically get that mechanical grip on the data. They decide, which parts of the data they want to focus on, and they decide what codes they're interested in exploring. But quantitative ethnography kind of opens up two avenues for additional ways of thinking about that, right? So one of them is that in QE, you can construct automated codes. I mean, you don't have to be in QE to do it, but in a QE framework, you actually, there's some tools for inter-rater reliability and validity that are better than some of the other things that are out there. So you can construct automated classifiers that essentially allow you to code large amounts of data relatively quickly. So that's sort of one way in which you can leverage quantitative methods to be able to look at more of the data. But more than that, once you've done that, you can actually construct exploratory epistemic network analysis models. So you can take the codes that I think this might be a code that's worth trying. I'm going to develop a classifier for it. I'll do that for 4 or 5 or 6 things, and then I'll look to see what the relationships, what the pattern in the data is. And now that gives me a place to go back and look and see, okay, well, what's actually going on there? Is this actually something that's meaningful or important in what I've seen? So people definitely do that. Personally, I think that the best work actually still starts qualitatively. That is, rather than just coming up with a bunch of codes and seeing whether or not there are relationships among them, actually doing the hard work of that focusing in, I think results in better work because your story is better grounded and you're using the quantitative tools principally to warrant theoretical saturation rather than as a discovery mechanism. But that having been said, lots and lots of people take that more discovery oriented approach. Where it breaks down often is they don't actually then go back and do the hard work to see whether or not what they've discovered is actually a particularly meaningful pattern in the first place. So they tend to go, oh, I found a pattern and I looked at a couple examples and yep, that's the pattern. And then they tell a story. And that's obviously, I mean, you can do it, but I just don't think it's quite as robust as if you've actually done the hard qualitative work. I mean, so one of the things that happened, that's been happening, I just finished a paper that is about a different method than epistemic network analysis, but also sort of in the kind of quantitative ethnographic world. It's about multimodal data analysis. And again, something quantitative people are like, wow, and qualitative people have been doing this forever. But one of the things that I realized as I was writing is like doing this, actually thinking about multimodal data and representing it appropriately, and it's, you know, to capture the different properties of the data and representing that in terms of the appropriate, you know, mathematical functions that describe what we think is going on qualitatively, yada, yada, yada. It's hard work, like really hard work. And it bumps up against people in the learning analytics, which is kind of the cognate field to learning sciences that I'm most part of now, who are like, well, but I could just run a topic model and have the machine automatically code my data, and then I could put it into a process model and I would get, you know, do process mining, and I'll get a network that represents the codes, and I can compare two different groups and I can find that they're statistically significantly different. And it's so easy. Why would I want to do all this hard work? I'm like, research should be hard work. Like, I mean, I hate to say it, but we're making claims either about the world in general or about specific people and what it is they were doing and why they were doing them. And like, we should actually have to work hard to do that. So I don't necessarily take it as a bad thing that as you know, in ethnographic context, we collect a lot of data and then we have to figure out what to do with that data. And we spend a lot of time looking at it, and it's hard and it's frustrating because it should be. You know, I know that it's tempting to take those shortcuts, but I think we generally, if you're taking a shortcut, you know, you kind of get what you pay for. So.
Any
Thank you for the talk.
Go ahead,
Yeah,
Samantha.
go ahead.
Thank you for the talk. I'd like to kind of piggyback on the answer you just provided related to your visualization. I'm curious about what sort of revision of your visualization of quantitative ethnography that we're looking at right now. And especially since you were putting a lot of emphasis on the qualitative components, you know, is there reasoning for them to be in the same font, even if you might believe that the qualitative component is super important? Is there a reason that it's on the bottom, since you're talking about that it like grounds the work, or, you know, and maybe why you chose the certain like repetitive nature of repeating the method 4 times, and, you know, just the details of this version, and if you were, you know, in the process of revising it, what revisions might you make?
Oh, it's a great question. I don't usually get questions about the graphic design in my talk, but so let's see. So top and bottom, no particular reason. One of them had to go on the top and one of them had to go on the bottom. I love it that you came up with a really good explanation for why it's on the bottom, but no, there was not. You could say I could have put it on the top and said it comes, you know, it needs to come first. What I would say is that in thinking philosophically about quantitative ethnography, one of the things that I have tried very hard to do is to be agnostic about the two methods, in the sense that I don't actually think that one method is better than the other. They're actually designed to do different things. So comparing them is a little like comparing apples and oranges. I like, they're both fruit. I like them both. Like I could put them both in a fruit salad and it would be good, but I use them for different things. Like I mix apples with different things in a drink than I mix oranges with. So part of what I have tried to do in constructing this, I think of it as a unified method, right? So it's actually bringing qualitative and quantitative, it's not mixing them. It's not a mixture in the sense that those of you who remember chemistry, right? A mixture is when you put the two things together and they remain separable. So like chicken soup is a mixture. I have the broth, I have the chicken, I have the carrots, whatever else you put in the soup. I eat them together, they're delicious. When I'm done, I can take the chicken out of the soup and it's still chicken. The soup is still soup. The carrots are still carrots. On the other hand, if I make lemonade, right, literally I'm putting the sugar and the water and the lemon juice, and when I mix them up, there's kind of no way to take the sugar back out. I mean, there is, you could distill it, but like it's become something else. And the something else in chemistry is a solution. Right? So in a sense, what quantitative ethnography is trying to do is not to construct mixed method, it's trying to construct a research solution. There's a unification of qualitative and quantitative methods that goes where the two are kind of fundamentally intertwined and fundamentally changed. So in doing that, I think it's very important not to say that one is better than the other, partly because I don't think it, and also because rhetorically it doesn't work very well if you do that. So that's part of why there's the sort of parallelism in the diagram. That having been said, that doesn't mean that certain pathways through the space don't tend to wind up at things that are more robust. Right, so the problem isn't starting with quantitative methods first. It's that when you start with quantitative methods first, at least in the sense we were just describing, coding and then running a model, and then it's tempting to not go back and circle back and close the loop and actually do the hard work, some of the hard work that comes after it. So it's not that there's anything better or worse about it in some philosophical sense. It's a pragmatic question. Right? So if you ask me, what do I advise you to do? That's a different question than what is it that you can do from a data philosophical sense that will lead to, good research and good warrants. You could do it both ways. That having been said, I think one of the things that has been problematic in the QE field is that because it was originally, the sort of philosophical underpinnings were originally constructed to be agnostic in that way. That is to say, look, these are two things, they're both valid, and we're going to put them together, and we want to put them together in a way that kind of philosophically respects the validity of both, but gains from the integration of the two. Is that some of the best practices, some of the sort of ideas about best practices have got lost in the shuffle a little bit, right? So, if you ask me, I would say, I think the right way to do it is do the qualitative work first. But philosophically, it's not that you have to do that. It's just like, empirically, that's kind of what leads to better results. So that's been, I think, one of the things that the community as a whole has been, I wouldn't even say they're wrestling with it. It's more like they're tripping over it over and over again. So there are discussions in the QE community about like people who have lots of Q and not enough E. And so there's like, oh, I did an EA analysis and I did this and this and this. And you're like, well, okay, where's the E part? Like, did you actually do the work of, understanding what's going on? Because otherwise it's just a fancy quantitative analysis. So that's a long way of answering a question, which is the diagram is probably okay the way it is for now. I could build a version of it that's like what I think you probably should do, which is different than the way this lines up conceptually. That helps.
Yes, thank you very much.
You're welcome. And I didn't choose the font, by the way. We have a graphic designer that I work with, and he chose the font. So I don't take responsibility for the font or the colors. Actually, he did the colors and the font. You'd be surprised. So the lettering, the thing across the top, I actually don't usually do on slides. I'm not going to try and pronounce your name again, but the gentleman from University of Georgia. Like when I was talking with Joel, and when I teach the course, we don't put banners across the top. But this actually came because I've been giving talks more and more to people who are not native English speakers. And if you produce slides that are very image heavy as opposed to text heavy, like if you put up bullet points, people who are not necessarily native speakers can often read the text better than they can understand the kind of flow of words. So this is kind of compensating for that. So it turns out that it took us about a day to figure out what color to make the banner at the top and what color to make the text so that the blue popped, but the gray didn't fade back too much. Like, it's actually, when you actually start to like work with somebody who really knows about graphic design, it becomes very complicated very fast. So I'm saying the color choices weren't actually that easy to get.
Any other questions today?
So I'm happy to hang around after we formally close if there are people who either want to know more about the conference or want to talk about their specific work or think about what they might do to start using these methods, in a way that is not something you would necessarily want to talk about it in front of the whole group.
Or on record?
Or on record, sure, or on record. Yeah.
Okay, so let's wrap up the formal part of this program, and anybody who wants to stay and talk informally can do that. And I think that makes the most sense.
Yeah, well, thank you all. These were great questions, and I really enjoyed chatting with you all, and I'm delighted that some of you actually enjoyed the talk.
It was great. Thank you.